On this video, we're going to see how we can use matrix inverses to solve systems of equations. And so what we're going to do is we're going to solve this system of linear equations, and we're going to use matrices and inverses to do it. Now, specifically, I want to talk first about how this system can be rewritten like this. Like, you might be saying, how is this really the same thing as this? But if I look, let's look at this left side of the equation and think about this. We're multiplying a 2 by 2 matrix times a 2 by 1 matrix, okay? And I think you see if I multiply these two matrices together, you're going to end up with this basically on the left side of the equation. Because if you know how to multiply matrices, you know first I'd multiply this row times this column, so I'd do 1 times x plus 1 times y. And then I multiply my second row times this column. I do negative 3 times x plus 1 times y. And so what you see is this left side is really the same thing as this left side of our original system right here. So I'm just saying that to give you some background. Don't be freaked out by how I got to this point. You can rewrite, oops, I'm trying to erase. You can rewrite your matrices in this form by just using the coefficients and then doing a 2 by 1 matrix with an xy. So hopefully now you trust me that this system can be represented with this matrix. And so now I want to name each of these three matrices. It's like we have a 2 by 2 matrix here. Let's call that matrix A. We've got our solutions, which I'll call X. I'll call this matrix X because if I can figure out what these numbers are, that's the solutions to our system. That's our X and our Y from these equations. And then let's call these values over here to the right B. So what we have is this situation where A times X equals B. And I'll kind of come up here because I don't want to erase this. I want to use this as a reference. So if I have A times X, and that's equal to B, what I want us to see is it's kind of like using the laws of algebra to solve for X, but since we're talking about matrices, the game's a little different. Since I can't divide by A on each side, we can't divide by a matrix, but what I can do is I can multiply each side by its inverse. So for example, if I were to take this same situation, AX equals B, what we know is I can multiply the left side of this equation by A inverse as long as I do it to the right side. And I'm going to left multiply both of these. Okay? And so here's why this is important. If you watch my previous videos on inverses, you see this and you recognize, oh, if I multiply a matrix times its inverse, what you're left with is the identity matrix. So we have identity matrix times matrix X equals whatever A inverse B is. And when you multiply a matrix times its identity, what you're left with is just that matrix itself. It's kind of like in matrices multiplying by 1. It doesn't really change the value of a matrix to multiply it by the identity. And so here's why all this stuff's important. And these symbols may throw you off, but here's the moral of the story right here. In order to figure out matrix X, which is what the solution to our system is, we need to multiply A inverse times B. If I can multiply the inverse of this matrix times this matrix, that's going to give us the values for X and Y. So I give you all this, give us our background. Here's the direction that we're going. Let's jump into it. So my first little submission is let's figure out what A inverse is. Okay? So A inverse, if you watch my previous video on inverses, is going to be 1 over the determinant of A times matrix A with a few changes. If I take matrix A and I interchange these two diagonal rows, I'd interchange those, but the 1 and the 1 don't really matter. And then I negate the other two rows, so I make that a negative and that a positive. If I can figure out what this is, that's going to be our inverse. And so as I do that, so our A inverse, let's just figure out what the determinant of A is. So I do 1 over the determinant of A. The determinant of A is 1 times 1 minus 1 times negative 3. So it's 1 times 1 minus 1 times negative 3. In other words, it's 1 minus negative 3, or in other words, 1 plus 3. So if I can multiply the scalar of 1/4 into this, that's going to give us our inverse matrix. So we're almost there on finding that inverse. So I'm just going to multiply each of these 4 elements by 1/4 to find that inverse. So we're going to have as our top left element, we're going to have 1/4. Then we're going to have negative 1/4. Then we're going to have 3/4. And then our bottom right element will also be 1/4. And so we did all that work to find our inverse matrix, which That's what we want here. Now we just need to multiply that inverse matrix times matrix B, and boom, we got our answers to the system. So I'm just going to multiply this inverse matrix times matrix B to get our answer. So I'm going to kind of come up here to do that. We're going to do A inverse times B. So our A inverse, oops, be color coded here. Our A inverse is 1/4, negative 1/4, 3/4, and 1/4, a lot of fractions, times matrix B, which is 6, negative 2. Now, in order to multiply these, we know that we've got a 2 by 2 matrix, and we're multiplying it by a 1 by 2 matrix, multiply it by 2 by 1 matrix. So these two numbers tell us that we can multiply them, and this one tells us that our answer is going to be a 2 by 1 matrix. Okay, so just a little background. I'm not going into detail about how to multiply matrices, but here we go. I'm going to multiply this row times this column. So we have 1/4 times 6 plus negative 1/4 times negative 2. Negative 1/4 times negative 2. And then we need to multiply the second row times this column. So we do 3/4 times 6 plus 1/4 times negative 2. Now, I should have used my colors because what this answer is that's going to be our x. If we multiply A inverse times B, it's going to give us the solutions to our system. So let's kind of do the math here. Up here, 1/4 times 6 is going to be 6/4, which simplifies to 3/2. Okay? But we're going to add it to negative 2 times negative 1/4. A negative times a negative is a positive. 2 times 1/4 is 2/4, aka 1/2. And then on the bottom we have 6 times 3 is 18/4. And then we're going to add that to negative 2 times 1/4, which is negative 2/4, or negative 1/2. So our last step is let's just do this math to find our elements. 3/2 plus 1/2 is going to be 4/2, or 2. And then 18/4 plus negative 1/2, let me kind of get a common denominator here. Let's leave that as negative 2/4. 18 plus negative 2 would be 16/4, and 16/4 is just 4. Okay, so our solution is 2, 4. That's our solution matrix. That means x is 2 and y is 4. That's the solution to this system of equations. 2 plus 4 is 6, and negative 3 times 2 plus 4 is, looks like I have a typo on the very first step of this thing, don't I? I hope that doesn't. Let's pretend that's a negative 2 the whole time, because I worked it out as if it were a negative 2. But let's this video is getting long. I was going to do another example, but let's stop there. Hopefully you get the main idea.